Hi, I'm Patrick Brannon, Mr. Patrick, from the Highlands Biological Station. This is a pretty big tree, but what do we really mean when we say big? Do we mean tall, wide, big around? Well, that's the subject of today's lesson. We're going to learn some different ways to measure trees. The first measurement we'll take is how big around the tree is. That's called circumference. Measure at about chest height, because a lot of trees kind of flare out at the bottom. Take your tape measure and simply go around the tree. So this tree is approximately 25 inches around. Another measurement we can take is the width of the tree, or its diameter. This isn't the most precise way of doing this, but take your tape measure, hold it on one edge, and measure across to the other edge. So this tree is approximately 8 inches in diameter. There is a more precise way of doing this. Foresters use what's known as a DBH tape. It's a special tape measure that's calibrated to measure the diameter and not the circumference, even when you wrap it around the tree. Or you can calculate the diameter from the circumference. We can calculate the diameter from the circumference using this very simple formula. D for diameter equals C for circumference divided by pi. Pi is a special mathematical symbol that we use when we are doing calculations on circles. Pi is approximately 3.14. So, D equals 25, which is our circumference, divided by 3.14. So the diameter then is 7.96 inches, or approximately 8 inches, which is what we measured. Next, we're going to learn how to measure the height of a tree. Now that's a really big tree. I don't think I'm going to climb the tree with a tape measure to figure out how tall it is. But there is a very simple way that you can estimate the height of a tree. To estimate the height of a tree, you're going to need a partner. Have your partner stand at the base of the tree and then measure how tall they are. So my partner is approximately 5 foot 7 inches tall, or 67 inches. Next, hold out your hand with your thumb up like this. Then slowly back up until your thumb appears to be as tall as your partner. Now my thumb is approximately the same height as my partner, which means my thumb now equals 5 foot 7 inches, or 67 inches. Let's see how many of my thumbs it takes to get to the top of the tree. So 1, 2, 3, 4, 5, 6, 7. So approximately 7 thumbs tall. So with this information, we can calculate an approximation of the tree's height. It took 7 thumbs to get to the top of the tree. And each thumb was 67 inches. Multiply that, and it's 469 inches tall. That's the height of our tree. But we want to convert it into feet. There's 12 inches in a foot. So 469 divided by 12 is 39 feet. That's the estimated height of our tree. But how does the size of the tree relate to its age? This tree doesn't look like very much, but it is actually a champion tree. This is a clammy locust, and for its species, this is actually a pretty big and old tree. So you can't really go by the size to determine its age. To do that, you need to look inside the tree at its annual growth rings. Tree rings are formed as the tree grows. The center represents the tree as a little sapling, but each year it adds a new layer of wood. In the spring and summer, the tree grows, but in the winter time, when it's colder, growth stops. Then next year, it starts growing again. This cycle is repeated, and so each year it forms an annual ring. So by counting the rings, you can age the tree. This tree has 5 rings. However, this tree is about the same size, but it has nearly 20 rings. So why isn't it 4 times bigger than this one if it has 4 times as many rings? This tree has more rings, but they are narrower rings. That tells you the tree didn't grow as fast each year. So it lived longer, but grew less. Different environmental factors can cause this, like if the tree grew in really dry conditions, or in poor soil, or in a colder climate, or it could be a different type of tree. So the size of the tree doesn't necessarily tell you the tree's age. You've got to count the rings. Most of the forests in the southern Appalachians are second growth forests. They've been logged in the last century or so and have regrown. But a few of the original trees still remain. This poplar tree is over 500 years old. Now obviously a giant tree like this is old, but some small trees are equally as old, especially those growing out of rocky cliffs. Some of these small stunted trees that you see can be hundreds of years old. They're just very small because they can't grow in the poor conditions. The dry rocky soil, lack of water, and exposure to freezing winds. Here at the Highlands Nature Center, we have a cross-section of a hemlock tree that is 439 years old. You can see how large it is. It was cut down in 1927, which means it started growing way back in 1489. And it's a very large tree. However, this smaller tree is actually more than 500 years old. It grew on the top of Little Scaly Mountain in a very rocky cliff face, and it grew less because of the poor soil conditions and lack of water. Scientists examined the rings in this one, and they are only 1 cell thick, so it grew very slowly. So even though it's stunted and a very small tree, it's still very old. Thanks for watching. Please visit us at highlandsbiological.org, and I hope to see you soon.